Okay, so let's take a look at the theory of logarithms. So by definition, we know that the logarithm of a number n to the base a written as this, log n to the base a, is the power to which a must be raised to obtain n. So from this definition, we know that if we would write out this particular value, let's write it out, and we're going to have log n to the base a, and they are actually saying that a raised to power what will give n. So that's just it. A raised to power what will give n. So let that power be x, because we don't know it, so you can say equals x. So you're actually asking a raised to power x must give n, since you made the unknown power be x. So that's it. So then you can now rewrite it as an initial or an exponential equation this way. So you now say, since you said a raised to power x must give n, then write it exactly the same way as a raised to power x equals n. It now becomes an initial equation. So that means if they write it in full for you like this, they give you another logarithmic equation. Let's say they wrote log v base n. So if you have log v base n, well, let's say you have log v base n equals t. So if you have it this way, it actually means that n raised to power t must give you v, exactly what we did here. So here we wrote a raised to power x equals n. So here it's going to be the same thing. N raised to power t must give v. So now let's see another example, maybe using real numbers instead of using variables this time around. We could see log 1000 base 10. So you see, and it's asked you to evaluate this. So you're still going to ask yourself, 10 raised to power what will give 1000? So do the same thing you did previously. Let that power that you're looking for, let it be x. So we are now going to say 10 raised to power x must give 1000. So that's it. Then you write it out as an initial equation. So you write it out the same way. 10 raised to power x equals 1000. Then you have 10 raised to power x equals 10 raised to power 3, because 1000 can be written as 10 raised to power 3. And at least both sides will be 10 raised to power something also. So now the bases can cancel out the bases, and you now have x equals 3. That is to say that 10 raised to power this 3 must give you 1000. So that's it. So we could see another example. Maybe we'll have log 16 base 2, and you are asked to evaluate the same thing. They're asking you 2 raised to power what will give 16. Since you don't know it, equate it to x. So x is now the power. X is now the power that you raise 2 to get 16. So you now show it. 2 raised to power x must give 16. That's the ultimate rule here. 2 raised to power x must give 16. Then write it out. 2 raised to power x equals 16. Then you have 2 raised to power x equals 2 raised to power 4. Then 2 cancels 2. Then you have x equals 4. That is to say that 2 raised to power this 4 must give 16, since this 4 is now the value for the x. So even if they write it this way for you, they give you the logarithmic equation in this way. They wrote log TMVRA base n equals to p. The rule doesn't change. What's the rule, or what's the number one definition? N raised to power this value here must give you the number for the log. Very important. So the base raised to power your result here must give you the number of the log here. So we now have n raised to the power p equals TMVRA. Very easy. They could also make the base the unknown, like having it this way: log 8 base x equals 3. So this time around, the base is now the unknown. It doesn't change anything. We still know that the base raised to power your result here must give you 8. That is the number one depth. That's your game changer. So write it out. You now have x raised to power 3. Exactly what I said. X raised to power 3 must give you 8. Write it the same way. X raised to power 3 equals 8. Then you now have, then the power for x will distribute and become a power for 8. And when it comes and becomes a power for 8, it becomes 1 over 3. So the x will now be free without the power. You now have x equals 8 raised to power 1 over 3. And of course, following law of indices, x equals, draw your root sign and put your 8 and put your 3 here, becomes the cube root of 8. And you could put your power 1. Then you now have the cube root of 8. And what's the cube root of 8? The cube root of 8 is 2. So you now have x equals 2. That is to say that the power for x, the value for x rather, is 2. That means 2 raised to the power 3 must give you 8. Okay, let's see another example. We're going to have it this way: log x base 2 equals 4. The ultimate rule doesn't change, that the base raised to power your result here must give you the number of the log. That is your game changer. So write it out. We now have 2 raised to power 4 must give x. And what's 2 raised to power 4? That's 16. That's 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 in 4 places. That's 16 equals x. So we now have x equals 16. So that's the value. That's the value for x. So that means 2 raised to the power 4 must give 16, which is the x we just found. So that's it. So in the next example, we are going to look at the laws of logarithm, and we're going to solve more examples there. So that's it.